Now I'm going to show you how to find the correlation coefficient, which is the second learning objective of this lesson. We're going to explore this concept by looking at real data. Here we're going to consider the table below. The table below contains data from the first 2 decades of AIDS reporting. Notice, on this table we see 3 different variables. The first variable being the year, the second variable being the AIDS cases diagnosed, and the last and third variable being the AIDS deaths. Now, if we're going to find the correlation coefficient, we need to decide what 2 variables we want to compare. We need to select 2 variables out of the 3. We cannot do all 3. Okay? Notice, in part, you're being asked to focus on 2 different variables. We're going to be looking at the data coming from the variable AIDS cases diagnosed and the variable AIDS death. We're going to be creating a scatter plot with these 2 variables, and we're going to be finding the correlation coefficient, and we're also going to be finding the equation of the regression model. Recall that the regression model equation is of the form y equal to a plus b times x. So if you find a and you find b, you should be able to write the equation of the regression model. Now, recall that your b value is the slope and the a value is the y-intercept. Now, you might be wondering, do we have to use the letter a and b? The answer is no. You could also simply say the slope is equal to this value and the y-intercept is equal to this other value, okay? You don't have to use a and b. Once you find the regression equation, then we're going to use that regression equation to make a prediction. We're going to ask ourselves, if we know that x is equal to 60,660, then can we predict the value of y? I'm going to show you how to do this using Google Sheets, okay? First, I'm going to copy the table, and then I'm going to go to Google Sheets and I'm going to paste this table. So simply click on an empty cell and press Control V or Command V. And here we have the table. So again, we said that we were going to use the last 2 variables on the table, the last 2 columns. We're going to highlight these columns. Then we're going to click on Insert and we're going to click on Chart. Let's go ahead and change the type of graph we want. We are going to look for the scatter plot. Click on the scatter plot, and there you have it. Notice, we do see a linear relationship. In fact, we see a positive linear relationship. Notice, as the x values increase, the y values increase. Or you can also see this as the number of cases diagnosed increases, the number of deaths increase. So I just wanted to create the scatter plot to ensure that we do see a linear relationship. Now, we're going to find the correlation coefficient. So I'm just going to type R in one of the empty cells. To the right of that cell, I'm going to type in equal CORREL. This is going to be the function that we need to use to find the correlation coefficient. Here, I need to select the y values. In this case, the y values are the number of deaths. So we're going to go ahead and highlight all these values. Then we're going to type a comma. And then we're going to highlight all the x values. In this case, the x values are the cases diagnosed. Let's go ahead and close the parentheses. And there you have it. This is your R value. This is the correlation coefficient. Now, let's find the slope of the regression model. Okay? To find the slope, we need to use the function equal slope, open a parentheses. We need to select all the y values, type a comma, and now select all the x values. Close the parentheses and click Enter. And press Enter. Okay? And there you have it. That is the slope of the regression model. Okay? Now, what about the y-intercept? To find the y-intercept, we're going to use the function equal intercept. Go ahead and open a parenthesis and again, select all the y values, then select all the x values. And there you have it. That is your y-intercept. Now I'm going to go ahead and round. For the R value, we're going to round to 2 decimal places. Our final answer is going to be 0.97. Now for the slope and the y-intercept, I'm going to go ahead and round to 4 decimal places. Now for the slope and the y-intercept, we usually don't round. And the reason we don't round is because we use this model to make predictions, and we're going to be able to make a better prediction if we don't round our answer. Now, just for simplicity, I'm going to round to 4 decimal places. For the slope, we're going to round to 0.6074. For the y-intercept, we're going to round to 4 decimal places, so we have 88.7161. Now let's go back to our notes. Here, remember, the A value is the y-intercept. We said that the A value is 88.7161. The V value is the slope. We said that the slope is 0.6074. The R value is 0.97. The equation line is going to be equal to the A value plus the V value times X. Using this equation, we can go ahead and make a prediction. We can go ahead and determine what we expect Y to be when X is equal to 60,660. Okay? To make this prediction, we would take our model and we would let X be equal to 60,660. So go ahead and compute that on your calculator. Here you should be getting 36,933.6001. And here it would make sense for us to round to the nearest whole number, right? Because remember, the Y value represents the number of deaths. So it has to be a whole number. So we would round to 36,930. So think about what we're saying here. We're saying if we have 60,660 cases that were diagnosed, then we are expecting 36,934 deaths. So that is the prediction that we're making here. Now here, I want to take the time to talk about the R value because this is the main focus of this lesson. Notice the R value is positive and the R value is really close to 1. This is telling us that we have a strong positive linear relationship. And here's the note that I want to make about this. Since we have a really strong linear relationship, then we know that the equation here below, the regression model, is going to help us make good predictions. So again, because we have a strong relationship, we're going to be able to make good predictions with the regression model. So oftentimes, when you're working with real data that you have collected, you're going to create a scatter plot. Looking at the scatter plot can help you anticipate if you're going to have a strong linear relationship. However, we do want to find the R value. The R value is going to indicate whether we have a weak, a moderate, or a strong relationship. If you see that your R value is really close to 1 or -1, again, that means that we have a strong relationship. That means that if we come up with the regression model equation, that equation is going to help us make good prediction. We're going to be really confident about the predictions that we're making. I'm going to let you do B on your own. Here, you're going to be considering the data coming from the variable year, and you're going to be looking at the data coming from the variable age cases diagnosed. You're going to create a scatter plot with these two variables. You're going to find the equation of the regression model. You're going to find R, and then you're going to make a prediction with this equation. Now, one thing that I want you to ask yourself is this a good prediction? How can you answer that question? Well, look at your R value. If your R value is really close to 1 or -1, then you have a strong linear relation. That means you're going to be able to make good predictions. Now, if R is closer to 0, then we're expecting that regression model to not give us good predictions.